Welcome everyone. So let's start a new lesson today, and I hope you all have get some of the idea about today's topic. All right. So what will be our today's lesson? Yes, of course it is heat. So let's start a lesson heat, and this is a part 1 video of this lesson for class 10. Okay, so before starting the lesson, let's understand what is the difference between heat and temperature. So student, we often get confused between heat and temperature. Okay, if it is because they are quite closely related. If we look closely, thus there are some differences between them, though they are interrelated or interconnected. But there are some differences between heat and temperature. So now let's learn about the difference between these two. So first, what is heat? Heat refers to the transfer of thermal energy, that is heat energy, that takes place between molecules within a system. And the unit of heat is joule. So this is about heat. And let's see the temperature. So the temperature refers to the average kinetic energy of molecules present in an object or system. So this is temperature, and temperature will tells us the highest or the least temperature of the body or a substance. So the unit of temperature is Celsius, that is degree Celsius, degree Fahrenheit or Kelvin. So this is a basic difference between heat and temperature. Now next question is, what are the different ways of heat transfer? So we know here there are three different ways of heat transfer. First is conduction, convection and radiation. Now conduction, it is a heat transfer is taken place between two solids, like you can observe here the two in the diagram also. Conduction, okay, heat transfer is taking place between two solids. And next is convection, it is taken place within a liquid. And radiation, this is a heat transfer taking place in the air. So these are the ways of heat transfer. Alright, now in this video, in this lesson, we are going to learn about the concepts of latent heat of phase transformation. Second concept is anomalous or abnormal behavior of water. And third is dew point, humidity and specific heat capacity. So these all concepts we are going to learn in this lesson. But today we will study only about latent heat of phase transformation. So let's study. Alright, now first let's see first what is latent heat. So latent heat energy is energy absorbed or released. Okay, energy is absorbed or given away by a substance during a change in its physical state. Now change in its physical state, that means from gaseous to liquid, liquid to solid, or solid to liquid, liquid to gaseous, or gaseous to solid. Okay, that occurs without changing its temperature. That means it is a energy absorbed or released by a substance during the change in the physical state of a substance that occurs without changing its temperature. That means temperature will be same. So this is latent heat. Now here one experiment is given to demonstrate latent heat. Now let's see the points one by one. So first take a few pieces of ice. Here the ice cubes or pieces and thermometer is inserted in the vessel containing ice cubes, and this is a burner, this is a stand on which the vessel has been kept. Now take a few pieces of ice in a glass beaker as shown in the diagram and insert the bulb of a thermometer in ice and measure its temperature. You can observe in the diagram the thermometer is inserted in the vessel containing ice pieces, and put the beaker on a stand and heat the ice using a burner and record the temperature using the thermometer after every minute. It means after a particular interval of a time we have to record the temperature using thermometer. And as the ice is heated, it start melting and stir the mixture of ice and water. Continue the heating even after ice starts melting, and draw a graph of temperature versus time. Now here you will observe that the temperature of the mixture remains 0 degree till the ice melts completely, and if we continue heating even after the conversion of all the ice into water, the temperature of water starts rising and reaches up to 100 degrees Celsius. That means your temperature temperature changes from 0 degrees Celsius to 100 degrees Celsius, and at this temperature water starts converting into what? Converting into steam, and the temperature of the water remains constant at 100 degrees Celsius till all the water converts into steam. So this is a latent heat in which the solid is converted into the liquid and liquid is converted into steam without changing its temperature. Okay. Now to understand this, let's see the graph of temperature versus time. So this is the temperature versus time graph. And in this graph the line AB represent, this is the line AB, and this represent conversion of ice into water at a constant temperature, that is at 0 degree Celsius. Okay, and when ice is heated it melts at 0 degree Celsius and converts into water at this constant temperature, and the ice absorbs heat energy during this transition, that means from solid to liquid, and the absorption of energy continued till all the ice converts into water or liquid, and the temperature remains constant during this transition, that means from the solid, while converting the ice into liquid or water the temperature remains same. This will only absorb the heat and energy, but temperature will not be changed. Okay, and this constant temperature at which the ice converts into water is called as a melting point of ice, and thus during transition of solid phase to liquid the energy, the object, that means the ice absorbs the heat energy. Okay, and but its temperature does not increases, and this heat energy is utilized for weakening the bonds between the atoms or molecule in the solid or ice and transform it into liquid phase, that is a water. Now the heat energy absorbed at constant temperature during transformation of ice into water or solid into liquid is called the latent heat of fusion. That means heat, or whatever heat has been absorbed by the ice while converting into solid to liquid or ice to water, it is called as a latent heat of fusion. And the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called the specific latent heat of fusion. That means this is our specific latent heat while converting the phase of solid to liquid at a constant temperature. Now next we are going to study about latent heat of vaporization. Now student, once all the ice is transformed into water at the temperature of water starts rising. Okay, and it increases up to 100 degrees Celsius. From 0 degrees Celsius to 100 degrees Celsius it will increases, and the line BC, so the line BC in the graph represent the rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius, and thereafter even though heat energy is supplied to water its temperature does not rise. That means after increasing the temperature till 100 degrees Celsius the heat is continuously providing, but its temperature will constant, that is 100 degrees Celsius, it will not be changed, and the heat energy is absorbed by water at this temperature and used to break the bonds between the molecules of the liquid and convert the liquid into gaseous state, that is in the steam, and thus during the transformation from liquid phase to gas phase heat energy is absorbed by the liquid, but its temperature does not change, it will be 100 degrees Celsius only, and the constant temperature at which the liquid transform into gaseous state or steam, it is called as a boiling point of the liquid or water. So boiling point of the water is 100 degrees Celsius. Now the heat energy absorbed at constant temperature during transformation of liquid into gas is called the latent heat of vaporization, because here water is converted into steam. So this is the latent heat of vaporization, and the amount of heat energy absorbed at constant temperature, that is at 100 degrees Celsius by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. Now different substances have different melting points and boiling point. Like water, the boiling point of water is 100 degrees Celsius, but for another liquid it will be different. Okay, it will be varying from 100 degrees Celsius. So the values of melting point, boiling point and latent heat depends on the atmospheric pressure also. So student, that's it for today, and I hope you all have understood this. And for the melting point, boiling point of different liquid and different latent heat of different liquid, you can refer the page number 63 of your textbook science part 1. So that I hope you all have understood this. Next part we will continue in next lesson, in next video. Thank you.